In this video, we're going to be looking at converting a recurring decimal back into a fraction. Now, this is going to utilize some basic algebra. So if you haven't looked at any of the algebra section yet, this video is probably not for you. But if you've done some algebra already before, then you probably will be fine with it, okay? Just to give you a heads up. So, how do we do this? And how does algebra come into it? Is the other question. So it's a pretty neat technique, really. So let's take a look at 0.5 recurring. So this is 0.555555555 forever and ever and ever. What we're going to do is we're going to call that x. So let x be 0.5 recurring. Now the idea is that I am going to multiply x by some factor of 10. And what that'll do is that'll allow me to move the decimal point along, essentially. So remember when we were multiplying by multiples of 10, by powers of 10, that essentially moves the decimal point to the right. And the idea is that I move the decimal point to the right until my result syncs up with what I've got here, and then a subtraction can take place. Now, this won't make much sense to you if you haven't seen it in practice, so let's go through that. So this example, I'm just going to multiply through by 10, and it'll become clear as to why I'm going to do that in a moment. So I'm going to multiply it through by 10. So I'm going to get 10x on the left-hand side, and on the right-hand side, if I multiply this through by 10, I'm going to get 5.55555555 forever. So this is 5.5 recurring. Now the idea is that what I meant by getting them to sync up is that to the right of the decimal point, what is recurring is syncing up, so that if I were to subtract one from the other, then the recurring section would disappear, would cancel away. So I'm going to call this equation 1 and this equation 2. And I'm going to subtract equation 1 from equation 2. So I'm going to look at 2 take away 1. So we'll have 10x on the left-hand side take away x, which is 9x. And on the right-hand side, we've got 5.5 recurring, take away 0.5 recurring. So the 0.5 recurring parts go. They're gone. And I'll get left with 5 take away 0, so just 5. So then I can divide through by 9, and so x is 5 over 9. So that tells me that 5/9 is the same as 0.5 recurring, or vice versa. So 0.5 recurring is 5/9. Now, this process I will repeat over and over and over again as we go through these examples. Let's see it in another way, okay? Let's look at it in 0.01010101, okay? Where are we going to have to adapt our process to figure out what this is as a fraction? So we start off with x equals 0.01 recurring. Now, I need to think about what I'm going to multiply this by in order to get the 0.01 part syncing up. So if I was to multiply it by 10, what I would end up with, so if I multiply this by 10, just for argument's sake, if I was to multiply this by 10, I would get 0.1010101010. Okay, so what would happen is that the 0.1 that is repeating here and the 1.0, these are not syncing up, they are not the same. So multiplying through by 10 wasn't enough. So what I need to do is multiply through by 100 this time. What's going to happen is it's going to move the decimal point one more place to the right, and I will end up with 1.010101001. Okay, so if we call this equation number 1 and we call this equation number 2, again I can subtract equation 1 from equation 2. we'll have 100x take away x, so that would be 99x. And then 1.01 recurring, take away 0.01 recurring. Well, the part that's recurring will disappear, and I'll have 1 take away 0, so 1. And so x will be 1 over 99. And so that is 0.01010101 as a fraction. Okay, so this process does take some getting used to, okay, if you've never seen it before. And I'm going to go through some more examples of this in the next video. So if you haven't quite cottoned on to what's going on, and I'll also go through an example which I haven't shown here, which is when you have some numbers to the right of the decimal point before things start repeating. I'll go through an example of how we deal with that in the next video.